Good evening and welcome everybody to part 4 of 4 of the Casio Graphing Calculator Programming webinar series. As I mentioned, tonight we're going to be dealing with two of the more complex programming aspects of the Casio calculators. Those are the get key commands and the commands having to do with strings. And we're going to be using them to create a program that basically functions as a text editor. So the program would be a way for people to type text. You can think of it almost like a little miniature word processor. And by the time we're finished with this program tonight, we won't have a fully functional word processor by any means, but we will have a start of one and something that should give you a lot of ideas about how you can deal with text and how you can generally do anything with programs on the calculator that require the users to press particular keys. And when we're talking about this tonight, you need to not think about these keys on the calculator as necessarily doing what the text on them or above them says that they should do. When you use the get key command, as we're going to see shortly, all that happens is the calculator then knows which key is pressed or is expecting a certain key to be pressed. You can then have any action happen after that point. So it doesn't necessarily have anything to do with the text on the key. You're essentially being able to reprogram the calculator to do whatever you want when a certain key is pressed. So let's dive right in. We're going to go down to the program icon on the main menu. Again, we're using the Casio Prism CG10 model calculator tonight, which is the flagship model of Casio's Graphing Calculator series. But I'll emphasize again that the commands that we're dealing with tonight can be used on any of Casio's graphing calculators, the FX9750 G2, the FX9860 G2. All of the keystrokes are the same, and the programming commands are stored in the same place. The only thing we're going to get into tonight that is a little bit different is we're going to talk just briefly about the use of color on the Prism calculator and how you can use color as a programming command. We're going to use it in one particular place to color some text, and there's all kinds of different ways you can use color within your programs. I really only need to show you one way because color is used in the same way. It uses exactly the same command syntax no matter where you use it in programs. So that will be the only aspect of any of these programming webinar series that you can use on the Prism, being that it's a full color graphing calculator, that you cannot use on the other black and white calculators in Casio's series. But that's almost just a little aside and just to show you one feature that is unique to Prism programming. So let's go into the programming module. I've cleared out my program list for tonight so that we can start fresh. Again, if you have programs already in your list, perhaps from previous sections of this webinar, that's just fine. You may have things appear here. For the purposes of tonight, I do not have any programs there. I'm going to start recording my keystrokes using the Prism Manager software so that, again, as you're going back through this webinar, you can slow things down or stop and rewind and look through some of the different commands and make sure you don't miss anything. We're going to press the F3 key to create a new program. And we're going to call this program Text Edit. So we already have Alpha Lock on by default when we start a new program name, so we'll just start typing the keys that have the red letters above them that spell the letters of Text Edit. We've used up our full 8 characters. We'll press the Execute key, and now we're beginning our program. One of the things we learned previously in our webinar series is that it's usually a good idea to clear the user's screen when you start a program. So we're going to open up our Programming Commands menu by pressing Shift and then the Variables key, which has Program above it in yellow. Pressing F6 to get to the next page. F1 for the Clear menu, and then F1 again for Clear Text. Press Execute to end that command line, and we've cleared the text on the user's screen with that command. Now we'd like to tell the users a little bit about this program. And one thing that I haven't mentioned before when we've been outputting text, in previous sections of the webinar series, I've mentioned two different ways to produce text. One is with the display tool. I'll press exit here and F6 a couple of times to go back to the very first programming menu screen. One way of displaying text is with this output tool here, and that outputs text and then pauses and forces the user to press the execute key to continue operation of the program. And the other way that we've placed text on the screen is using the locate command on the second page of programming commands, and in the input-output menu, F4, we have the locate command, and that's the command that we used to place text in a very specific location on the screen. We can actually start that text at a given row and column using the 7 rows and 21 columns on the screen. But one thing I haven't mentioned before, and I'd like to emphasize tonight, is that you can place text on the screen with a command just by placing that text in quotes. No other special characters required. So I'm going to press Shift and then Alpha to go into Alpha Lock, and then press the key in the bottom center of our keypad to create the quotes. And then inside those quotes, I'm going to create some text. Now last time we learned about the ability to create upper and lowercase characters, so we're going to do that here. I'm going to press the exit key a couple of times to get out of the programming commands and back to the base program mode menu. And we're going to say something like, this program will allow you to type text. You can modify this message if you want it to say something else, that's fine. But we just want to give the user some message about what the program does. So we'll type the capital T. Oh, but you notice when I exited out of those menus, I also exited out of Alpha Lock. So that's something I show you again to remind you that immediately after pressing Alpha Lock, you need to start typing characters. So we'll just press the delete key to backspace that division symbol that was inadvertently typed. Shift Alpha again to go into Alpha Lock. And now when we press the division key, we get the capital T that's in red on that key. We'll press F5 to change to lowercase text, and then continue typing. This, space, program, space, will, and I'm going to create additional spaces until my cursor is right underneath the T. We've talked about that previously. That's to ensure that the word wrapping will look good on my screen. And then continue typing. This program will allow you to type text. And let's see if text is going to fit. You can see that we're overlapping the beginning of the line, so text is not going to fit. I'm going to back up here to before the word text. And just like I could in a word processor, I'm going to press space a few times until we're lined up and our word wrap is not a problem. Go to the end of the word text, press the alpha key to get out of Alpha Lock, type a decimal point, which looks like a period here, and then a quick closing quotes, alpha, close quotes, and press execute. So I have not used any kind of special display command. I didn't use the locate command. I just typed some text in quotes. And let's see how that's going to manifest itself when we begin running our program. So we'll press the exit key and then execute to begin running our program. And there the text displays quite nicely. And so you can see the third way to display text on the screen. You now know, if you've watched all the parts of this series, you now know all 3 ways to display text on the calculator screen using commands in a program. So press execute again to end the program, And let's press F2 to edit our program again, and F2 again to go to the bottom of our commands so that we can start to type a new command. What we want to do now is we want to allow the user to start typing text. And in order to start typing text, the user is going to need to press a key and have the key output a letter. We don't want the user to have to press alpha and alpha lock and mess with all of that same stuff that we've been messing with this entire time. We would like the user to just be able to type. So what we would like to do, for example, is we would like it that if the user pressed this X theta T key that has the letter A directly above it, when they're using our program, the only thing we want these keys to do is create letters. Nothing else. So we don't ever want this key to create X theta T. We don't ever want this key over here to create sign. We want only letters to be typed. So in order to do that, we're going to need to use the get key command. So the get key command is going to return to the calculator a code that represents the last key that was pressed. So let's first go and find the get key command where it's located in all of our commands here. We press Shift and Program to get our programming commands back. We're going to press F6 to go to the next page. And because get key has to do with the user inputting something, typing a key, creating input for the calculator, it's going to be in our input-output menu here, F4. Notice that this is where we had the command locate last time. Get key is the very next command next to it. So press F2 for get key. And let's press execute. And let's see just what typing get key does in our program. Let's experiment with it a little bit. Press exit a couple of times until we're back to our program list. Press execute to run the program. And then you see a 0. Now, why would the calculator output a 0? It doesn't seem like it even gave us a chance to get a key, to type a key. Well, let's edit our program again. One of the things you need to understand about get key is get key returns a code based on the last key pressed. So we first need to give the user the opportunity to press a key. And then we need to run get key to say, what did they just press? The reason we return a 0 is get key returns a 0 if it didn't sense that there's a key that was just pressed. So we're going to need to create a loop, and in this loop we need to have the calculator essentially continually checking to see if a key has been pressed. So let's go down to our get key command, and we'll press the execute key to move get key down to the next line. And then on the line immediately above it, we're going to create a while loop. If you've done any programming at all in any environment, you should be familiar with while loops. While loops continue to run while a certain condition is true, and then the loop spits you out once that condition stops being true. So it's a great way in a program of a program waiting and watching for something to happen, and then when that thing happens, to move you on in the program. So let's go and get our while command. We're going to press Shift and then the variables key to open our programming commands. And then we're going to press F1 for command. We don't want an if statement, so we'll go to the next page. We don't want a for loop, so we'll go to the next page again. And now we're going to have our while loop options. So we're going to say while, and now I'm going to go down to the next line and I'm going to move my get key command back up to this line. So I'm going to press delete. And what I want to say is while get key is 0. So while get key is equal to 0. So I'm going to go to the X key at the end of my get key command, press shift and then period to create an equal sign, and then type a 0. So while get key equals 0, remember that get key equals 0 means the user did not press a key. So while the user is not pressing keys, the great thing is we don't want anything to happen. If the user's not pressing a key, don't do anything, which means we can just simply go down to this next line and say while end and press execute. So while the user is not pressing any keys, continue in this loop. So this just marks the end of the loop. While the user is not pressing keys, keep staying in this loop, stay stuck, don't do anything. So what should happen now is when we run this program, if we actually press a key, the program should end. While we're not pressing a key, the program should run indefinitely. Let's check if that happens. Press the exit key enough times to get back to your program list. Press execute to run the program. Notice nothing seems to be happening. Let's press any key. I'm going to press the logarithm key. I'm pressing keys. I'm pressing keys. Nothing seems to be happening. Nothing seems to be happening. What about pressing execute? So apparently the program ended on its own. Let's edit and do some checking again. What we need to do is we need to go and look at, as I've commented and asked people to do in each part of the webinar series, we need to go and look at the documentation, at the manual in the programming section and see exactly what our while loop syntax is. So let's go into the manual, and we're going to go to the command reference, which is in Chapter 8 on Programming and number 5. And let me make this a little bit bigger for us here and give you a larger window. That should be more visible for you. And we're going to go look at this while end sequence here on Chapter 8, page 15. So I'll just scroll down here until we get to that page. And let's look at the while loop sequence. So this is, again, don't be shy about this manual. The manual has lots of pages, but when you're programming, you will refer to it often to make sure your syntax is correct. And this is ultimately how do you learn to program. You have to learn a language. So this command repeats specific commands as long as its condition is true. So while a condition is true, in other words, we said while get key is 0, then perform some number of statements, and then we end this with while end. Well, we need more information inside this loop before we know whether the loop is actually behaving, because what may have happened is we may have been pressing that logarithm key and our loop performed perfectly fine and we got kicked out of our loop and then the program ended. We need to see if we're actually getting kicked out of the loop when that logarithm key is being pressed. So what we're getting into now is really what's called debugging in a program. You're seeing if different components of your program work, and one of the best things that you can do as a programmer is to debug as you go along. Make sure that pieces of your program are working as you go along instead of trying to write a monster program and then wonder why everything's breaking at the end. It takes a lot more time to diagnose things when you have to look at them in large scale like that. So we're going to go down to the end of our program, and we're just going to type some text that tells us that we exited this loop. So we'll enter text the same way we did before, and because we're just debugging, I'm not going to care too much about uppercase and lowercase. I'm just going to go into AlphaLock, and create the quotes and say something like, you pressed a key. And close the quotes and execute. So because this is the bottom command of our program, we shouldn't get to this command unless we get kicked out of this while loop by pressing a key. Let's go test it. Oh, and do you notice what happened? It tells us that we pressed a key. So somehow we've been kicked out of that while loop. Realize that when you ran the program, you press the execute key. Now let's see if we can get key to tell us exactly what key was pressed. Let's press execute to end our program, edit to go back into our program. And right before you pressed a key, let's insert a command, and then let's get key to tell us what key it thinks has just been pressed. So we'll open our programming commands, go to the second page, go into the input-output menu, and we're going to say get key, store into alpha k. Remember, get key is going to return a number corresponding to which key was pressed. The keys are numbered, and I'm going to show you the numbering grid and diagram in your manual. This is a major thing that I find myself returning to the manual often. In fact, I have this page of the manual printed out so that when I'm using get key, I always know which keys are numbered what. We're going to store get key into k. And now we're going to go down to our debugging line, and we're going to change this line to say, you pressed key, going to alpha lock here, you pressed key number, and I see that number is too long, so I'm actually going to go and find the number sign. This is something we haven't used in a program before. I like to show off as many pieces as I can. Press exit until you go back to the very first menu that we get to when opening a program. And I'm going to press F6 for a special character. And if we scan through here, you can see a bunch of characters that would be difficult to generate. They're not really on the keyboard. I can look through and if I press symbol, I was on math before, but if I press symbol, you see all kinds of neat stuff that you can output to your screen. I'm going to go over here and select the number sign. And now it says you pressed key number. And then I would like to output this number k. So I'm just going to type a k and press execute. And let the program display the number k. So let's exit and run our program. And do you see what happened? You pressed key number 31. Key number 31? But why was it was telling me a 0 before when I didn't press any key. Okay, let's go check what key number 31 is. So we're going to go back to the manual here, and in the command reference, we're going to go to the get key command page, which is page 22 in our programming chapter. I went too far here. Get back to page 22, and we'll look at the get key diagram, the one I said I had printed out in front of me. So here's our get key diagram. I'm going to make this a little bit bigger, and hopefully you can see all of these keys. Here's the numbering diagram for the keypad. So key number 31 is in the bottom right-hand corner, and in the calculator, the bottom right-hand corner is the execute key. Well, think about what happened when we ran our program. In order to run our program, we press the execute key. Guess what? The execute key is number 31. So the calculator correctly tells us that the last key that we pressed is the number 31. You have to realize that the calculator is constantly storing in its memory information on the last key that was pressed. I mean, ultimately, when you're just typing and doing calculations on this calculator, it needs to always know what the last key that was pressed was. And it stores that memory until you press a new key, at which point it stores another key information. In fact, your calculator keeps track of many more keystrokes that you have pressed than just the last one. It keeps track of a whole array of keystrokes going back many, many keystrokes, and that's what allows it to have a good user experience when you're typing in calculations. It knows what you've done, and it knows kind of what's coming. So we need to get around the fact that we just pressed key 31. We need to delay the calculator a bit until, hey, wait now, I need to have an opportunity to press something else. So let's press execute, go back and edit our program. We'll go down to the bottom. And so what we need to do is we need to essentially throw out this 31 that we've just received. So let's go up to our while loop, and we're going to expand this statement. We're going to say while get key equals 0, or while get key equals 31. So we use the OR statement one other time in our programming series. You may remember that we get to it by going to the programming commands, going to the option menu, and then going to the next couple of pages until we get to logic, and then we choose the OR command. So let's see if we can expand our loop by saying if the user doesn't press anything, or if the user presses key 31, which is the execute key, then keep us stuck in this loop. All right, so let's find out. We're going to go back to the programming commands, go to the next page, input, output, and get the get key command again. While get key equals 0, or while get key equals 31. Stay in this loop. And let's see if now it will allow us to press a different key. Exit out of our program and run it. Ooh. You notice what's happening? Nothing after this text, which is great. We're stuck in a loop. And you know that we're stuck in a loop. The calculator is giving you a clue because it has this little spinning wheel up in the corner indicating it's waiting. The calculator is actually technically working during this time because it's running that loop over and over and over and over, waiting for us to press a key. So let's try pressing that logarithm key again and see what happens. Right away we're told, yep, you pressed key number 66. Outstanding. So we've now gotten the calculator to tell us exactly what key we press. Let's go back to our program and edit it. This is great, and we now debugged our program sufficiently so that we know that other than the execute key, the user can press any other key on the keyboard, and it will be fine. Now, we'd actually like to exclude other keys as well. We'd really like to stop the user from pressing any of the keys that do not have letters on them. We want the user to be able to eventually press the execute key in order to move down a line. We'd like execute to be kind of like a carriage return in our text program. But for now, we're going to exclude the execute key at first because it was stopping our ability to grab keystrokes. We'd like them to actually start typing something before they press the execute key and get a carriage return. So we need to exclude some other keys also. We need to exclude all of these keys, F1 through F6. We need to exclude shift and option and variables and menu. We need to exclude, well, we don't want to exclude the arrow keys because the arrow keys are potentially going to move our cursor through a program, so we won't necessarily exclude those. But we're not going to need alpha, so we'll exclude the alpha key. And then we're going to exclude the exit key. And you can see there's lots of keys on here that don't have the letters. So we need to exclude all of those and say those are not valid keys to be pressed. So let's go up to this line here. And this is where you can really use cut and paste to your advantage. I don't want to have to go into all of these menus to go and get the OR command, to go and get the get key command, to go here and there and everywhere and find all this information again. So what I'm going to do is clip a piece of this code and then copy it a whole bunch of times. So let's press Shift and the number 8 for clip. And now I'm going to scroll back here. And you notice that it doesn't always scroll one character at a time. The reason it's jumping over that word OR is the word OR is a command, and it knows that it needs to capture the whole thing. It can't just grab the R or the O because this is not text. This is a block command. So I'm going to grab this OR get key equals 31, and I'm going to press F1 to copy that. And then I'm going to go to the end of my line and press Shift and the number 9 to paste. And I'm going to do that a few times. This might look like a lot of OR statements, but we need them. We have lots of keys that we need to exclude. So going back to our diagram, we want to exclude 79, 69, 59, 49, 39, and 29 for sure. Those are the F1 through F6 keys. So let's go to each of these get key lines in order, and let's put in those values so that we ignore all of those keystrokes. 49, 39, and just check our list again, and we need 29. Okay, that's good. Now the user cannot press nothing, and they cannot press the execute key, and they cannot press F1 through F6. Let's paste 4 more times to wipe out these 4 keys as options at the top of the screen. So Shift 9 to paste, 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 and paste. Let's go up here, and we want to exclude 78, 68, 58, 48. The good thing is when you're looking at get key diagram, there's often patterns like that. So we can exclude those keys. Now, you can see that this technique that we're going through is going to create a massive, massive command line. If we press the exit key and go back, you can see that our program has already swelled from 88 bytes to 200 bytes. That's a large program. So if we go back into our program here and we realize, my gosh, if we're going to list all of these keys and say you can't press any of those keys, then we're going to have really, really long code. There's another way to get around this, and that is to realize that if the user presses a key that isn't execute or nothing, key 0 or key 31, then we just want the program to not do anything. We want it to not output a character. Well, that's fine. The user can press all kinds of different keys, and then we just want the program to keep listening until it gets one that it wants. So please don't think when we're putting in all of these OR commands or all of these OR strings at the end of our while loop here, please don't think that we're going to need to do this a whole lot of times. We just need the user to start pressing keys and then determine what to output based on them. So let's continue our process here. Shift 9. We now need to wipe out. Let's see. We need to wipe out the alpha key, and we need to wipe out the x squared key. No, x squared has a little r above it. Granted, that's an r for a radius for polar notation, but maybe someone will want to type that lowercase r. So we need to get rid of alpha, and we need to get rid of the exit key. So let's go look at their positions. They are 77 and 47. So we paste twice here, and let's put 47 here, and then let's scroll backwards and exclude key 77 here. And then go to the end of our list here, and the next two keys we need to exclude are the delete key. We might want to leave the delete key because that will allow a user to potentially delete a character, and that's what we actually need some of our string information for. So leave the delete key alone, but we do want to, and the AC on key, you're not going to be able to do anything about this key. When this key is pressed, if you look at your get key diagram, you don't even have a number for this because pressing AC on breaks out of your program. You can't stop the user from breaking out of your program. That would be bad form. So the only other key we need to exclude is this negative sign key down at the bottom right-hand corner. And on our list, we can see that that's key 41. So we'll do one more paste, and we'll exclude key 41. And if you decide later that there's other keys that you want to exclude for different reasons, suppose you wanted to exclude these two keys up here, you can just add to this list. So we can guarantee that when this loop is done, that the key that we grab is not going to be one of the excluded keys. It's not going to be in that list. Essentially, it's going to be one of the keys that has an alphabetic letter above it. And then we still have information down here that takes the key that was pressed and stores it into a variable. So we are going to have, sitting inside the variable k, a key number corresponding to the last key the user pressed. We're going to get rid of our debugging line now. I'm going to go to the end of this line and just delete all of this text. And now we need to tell the calculator what to do if a certain key is pressed. So suppose the key that they pressed is the key that has the letter A above it. Well, in order to produce the letter A, we need to say this key was pressed. If that's the key that was pressed, create a letter A. So we're going to create an if statement. Go into our programming commands and command and if, and we're going to say if that variable k, the key that was pressed, is equal to, and let's look at our get key diagram. That key corresponding to the letter A is the fourth key down on the left side, so it represents key number 76. So if k equals 76, then we would like to output a letter A. Now, in order to output a letter A and in order to work like a word processor typically works, we need to know exactly where the cursor is or where the user's output is going to appear. So let's leave our program for a minute, or leave the editing of our program. It doesn't matter that you haven't finished this command. The program will give you a syntax error at the end, and we'll deal with that. But let's run our program. It allows us to type text. And let's see where things would be output. So remember from before when we were debugging, our output text occurred right beneath the 3 lines of text we had before. So we have 3 lines of text. The next place characters are going to appear is going to be in the 4th line and the 1st column. So I'm going to press a key. There's key number 66, and that's fine. We're going to go to the bottom of our list again. Oh, then K. So that's why we didn't get a syntax error, because we still have this line that produces the number of the key that was pressed. So if K equals 76, then what? Then we want to output an A. And we're going to use the locate command to make that A appear exactly where we want it to. So shift program, next page, F4 for input output, and F1 for locate. Remember what our locate syntax is. When we use the locate command, we're going to say what column we want the character to appear in first, character or word or phrase or whatever you're placing. So locate in column 1, comma, row 4, comma, the letter A. So we do alpha quotes. Actually, we could have done alpha lock so that we get quotes, A, quotes. If they press the key corresponding to A, it's going to place an A in that position. If they press any other key right now, our program will just end. Always end your if statement with an end if. Again, programming commands, command if end, and press execute, and let's run our program. Program will allow you to type text. Let's type the key corresponding to A. It produces the A right where we wanted it to. And we can press execute. Now, if we want our program to always know where it is, where its position is, where the cursor is, we're not going to get into creating a blinking cursor or anything like that. That's a little bit more advanced. But if we want the program to always know where typing should be taking place, we can't have a bunch of these locate commands going on. We need to use variables. So let's go up above our if statement and insert a line. And we're going to use a couple of variables here. We're going to use C for column and R for row. And since we know that the first place that this locate command needs to fire is at row 4 in column 1, we're actually going to go to the top of our program, and right after clear text, we're going to define our variables. So we're going to define our starting column as column 1. So we're going to say 1 store into variable C, and press execute, and then we're going to store 4 into the variable R for row, way at the beginning of our program. Now we're going to go down to the bottom, and we're going to change this locate command. Instead of just specifically saying 1, 4, we're going to make this command more powerful by saying, you know what, we want you to locate at column C and at row R. If we run our program again now, you'll see that we're still going to create the letter A in the correct place. But the advantage is that once we type that character, we can now tell the calculator to make the next character appear at the next column over, one space to the right. So edit the program, go down to the bottom, and what we're going to do is insert a command. Remember that in an if statement, you can put any number of commands you want after then, and they'll all be inside this if statement bracket, so to speak, that goes between if and if end. So you can say if this condition caused these 84 things to happen. So we located A at this column and row, and then what we're going to do is increment the column. So we're going to say, you know what, you just used column 1, so the next time you need to use column 2. So we're going to take our current column, add 1 to it, and move it over to the next column. And then we also need to insert a command here that says if you've gotten past column 21, that means you need to go to the next row. So we're going to put another if statement inside our if statement to say shift program command if C is greater than 21. Where do we get greater than? We get out of the command menu, go to the next page, and we need a relational symbol. If C is greater than 21, if we're saying to go to a column greater than number 21, then go back to your command menu. If C is greater than 21, then a couple of things. Make C equal 1, in other words, store 1 into C, go to the first column of the next row. And that means we have to increment the row here, make R plus 1 be stored into R. If we run out of columns, go back to column 1 at the beginning of the next row. And then we need an if end for this statement as well. Okay, so we've got an if inside of an if. Create an A, and then move over to the next column. And if you go too far, go to the beginning of the next row. I'm going to clear out our keystrokes here so that we can continue to watch fresh. So far all we've done is be able to create a single letter A, and you might think, oh my gosh, how are we possibly going to be able to create all of these characters in a row? Well, this is where you start using something called a subroutine. So we don't want to have this if statement control everything. I mean, think about it. Think about if we had to take all of this code from this if statement all the way down to here and use that every single time that we wanted to locate a character. That would be a lot of coding and a lot of lines of code. So what we're starting to learn now as we get later in this webinar series is we're starting to learn how to be efficient with our code. And I'm starting to get into those topics more and more with us. For one thing, we don't need all of this column changing stuff and row changing stuff to occur inside of this statement. We don't need this to occur just if this key has been pressed. We need this to occur no matter what key has been pressed. So the first thing that we're going to do to try to make our code a little bit more streamlined is we're going to clip everything from here down, and notice how slick it is. If I press the down arrow, I capture the entire previous line. We're going to clip everything from the C+1 line all the way down to the first if end, and we're going to cut it. And we're going to place it at the end of our program. And in fact, I'm actually going to put in a couple of lines here before I paste so that we have plenty of space. This is now kind of a line separator to remind me, oh, this is the code that moves our row and column. Fine. Now what's happened is that this first if statement we had for pressing the key for the letter A, that first statement now is only a single command coming after the if statement. And you need to watch for this in your code. Anytime that you have an if statement that only has one consequence, you really shouldn't be using an if statement. You should be using a conditional arrow. And what I mean by the conditional arrow is in Shift Program and in the Input-Output menu, excuse me, not the Input-Output menu, the Jump menu. It's in the Jump menu for because it's related to these label and go to things. I actually wish that it would be in the same place as the if statement, because really this arrow is saying if whatever happens before the arrow, then whatever happens after the arrow. It's just like a conditional statement in our mathematics classrooms that we teach about when we teach mathematical logic or conditional statements. Same arrow. Same thing we use when we show that one equation implies another in algebra. If this is true, then this next equation must also be true. Same purpose, just in programming. So what we're going to do is we're going to use that arrow to streamline this if statement. We're going to get rid of if. So we're going to go to the left of the letter K here and press delete to get rid of the if statement. Then we're going to go after this 76 and press the conditional arrow. So this is saying if K equals 76, then do what comes after the arrow. Oh, so that means we don't need the then statement. K equals 76 says locate A. We also don't need if end. And now what we can do is clip this line that we just created, copy it, drop down to the next line, paste it, And all we have to change each time is the number and the letter that gets created. And we're not going to do all of these. I mean, it would take you a little bit of coding time to go A through Z and maybe create a space and things like that. We're only going to activate the keys A, B, and C. This is what I meant at the beginning of the webinar when I said that we're going to make a partially functional word processor, but give you the tools to make one of your own. So what's the key for B? Let's go look at our command reference. B is above the logarithm key, which is right next to 76, which is key 66. So we're starting to see a pattern. This needs to be key 66. And then let's go down one more line and paste again. And if we want to create the letter C, then that means that we need to look for key 56. And now all we need to do is cause this program to continue to look for keys, look for keys, look for keys. So we're going to go down to the very bottom of our code, go to our programming commands, the jump menu, and create a go-to command to label 1. Once we're done checking for a key and creating a letter, then we're going to change our row and column, and then we want to go right back up to our loop here, and we want to have the calculator listen for a key again. So we're going to go up above our huge while statement and create a label. So what will happen now is the calculator will listen for a key. If it receives an A, B, or a C, it will press it. Or you'll press it, and then it will create the letter, and then it will move to the next space over. If you press any other key, nothing's going to happen except that your row and column will get incremented, and then we'll go back up and start listening again. So let's exit here and execute our program. We're listening, type an A. Type an A again. Type an A again. You see we're pressing the key one time and we're getting lots and lots of different letters. Lots of letters. This tells us that the program is running this code many, many, many times in a short period of time. Out of domain, that tells us that the calculator is sick of listening. It's done with all of this listening stuff. Press exit. So the problem really out of domain is that we ran out of rows. The calculator had no more places to put letters. So what we need to do is after the key is pressed, we need to tell the calculator that we need to empty the value of K. We need to say, all right, if you've already located a letter, then we don't want K to have any key information anymore. So we're going to store 0 into K and see if that stops the calculator from producing so many letters at the same time. Press exit and run the program. Type an A. Up there they go again. There they go again. There they go again and again and again. You can see that we're getting many productions at the same time. So we have to go troubleshoot. I just pressed the all clear button to break out of our program. And let's see what's happening. Get key is storing into K. And then we're locating that letter A. And then we think that we've cleared out the value of K. But the problem is that even though we've cleared out that value of K, this get key command is still firing. This key is and it's saying, you know what, the last key you pressed was the letter A. And then it checks again. Yep, the last key you pressed is still the letter A. And then it checks again. Yep, the last key you pressed is still the letter A. So we need to slow our program down. Our program is checking things way, way too fast. Unfortunately, we've run out of time for tonight's webinar for me to be able to continue with this concept. I think actually we've created material now for another webinar. we need to slow this program down. So we'll save this text edit program, and we're now starting to get into some meta programming where you're actually telling the calculator what speed to perform actions. So I'll tell you what, I'm going to talk to our folks at Casio and see if we have room, maybe after some time passes here and you have some time to experiment with this, for another programming webinar or two where we dig into some of these things and we can actually dive back into this program. I actually didn't have any time to get into strings at all tonight and the storing of strings, and I would like to cover that with all of us because it's an entire menu area here at the end of the programming menu. This string menu is an entire set of commands, and a lot of people don't know what it does. It's very, very powerful. It allows you to receive text entry from a user. User can enter a whole string of text, and then you can manipulate that string and do different things with it. For instance, a user could enter their name, and you could store their name. That's one of the things that I'd like to teach us about. So we'll get together over here at Casio, and we'll talk about the next time that we can put together some programming webinars. In the meantime, if you'd like to contact me or contact anyone at Casio and you have programming questions in the meantime, we're happy to answer them. We're really trying to build a library of information that you can use to code and write your own programs. Hopefully, in our hour this evening, I've given you enough things to play with GetKey and the ability to locate text in certain rows and columns that you can start to play with this on your own, start to experiment. And again, our goal is for you to write great programs for the Casio graphing calculators that are out there for people to use and share and enjoy. Thank you very much for attending tonight. Feel free to watch all of the webinars in the series available on Casio's education website, and we'll see you next time.
Thank you very much, Mike, and thank you for those of us who joined us this afternoon or evening, depending on where you are. I really enjoyed this. I have been needing to get more into the programming side of things. That's probably my weakest area in our calculators. I know a lot of them, and but the programming is my weakest. And I just realized I neglected to introduce myself earlier. I'm Nathan Austin. I'm with Casio as our curriculum and online training manager. So thanks again, Mike. Thanks again, those who joined us. And we will be posting this video and the other previous videos in this programming series on our YouTube channel, the Casio Prism YouTube channel. So, and if you have any questions, feel free to contact us. My email is naustin@casio.com, and I can forward any emails on to Mike if you have questions for him. So, thanks again, and have a good night.